Hey there, folks. Sorry about the slight delay. I had a moment there where I was sitting there and I'm set and I'm ready and I'm like, okay, let's get to work. And then I'm thinking, oh wait, is my neighbor outside working? I hear some sort of whistling sound. And then I remember, no, Joshua, you have a kettle on the stove. You should probably do something about that before you spend the next hour working. Hey everybody, I'm Joshua. This is my lunch break game development stream where I make a little project over every lunch break. This is a week daily stream, Monday through Friday at noon Pacific time. I usually spend about an hour on this. My previous series was called Lunch Break Roguelike because I'm incredibly creative when naming things. It was a Twitch playable roguelike. That series is over, and now we're on a series I like to call BS.CHESS. This is a basically BS.CHESS is kind of like a little filler in between larger lunchtime projects. But basically, it's a Twitch playable chess game with little to no rules. And actually, let me flip over to this, and I've been trying to be a little bit more structured with this particular series. Yeah, so BS.CHESS, I call it a no holds barred, no rules chess game played through Twitch chat. Oh, hey, Louis Carl, thank you for popping in. So the series goals, my series goals are having a more structured stream. And the stream, I'm intending for it to follow more closely to the actual software development process. So for those of you who do know, or maybe if you don't know, the software development process is typically described, or traditionally described, as I should say, as a 5-step process, which you have requirements phase, you have a design phase, you have an implementation phase, you have a verification phase, and then you have a maintenance phase. And those are the 5 steps in a traditional software development process. So I'm trying to do like an agile development process where I go through those steps in an hour, which is crazy. And I've also shortened them into a design, an implementation, and a QA phase. Also, the second series goal is to use and develop the understanding of the MVC pattern, in particular, using the MVC pattern in game development. And that, for you don't, again, that is an application architecture that separates out logically the three kind of main areas of your program. One called the model, one called the view, and one called the controller. You can think of the model as just the plain old data that lies underneath the application. You can think of the view as everything that faces the user, so all the UI, the front end stuff, and then the controller deals with all the logic. The controller manipulates the model and drives, telling the view to update and that good stuff. Also, I wanted to, for this project, start working with you, the viewer, and allowing pull requests to happen. Unfortunately, the view component is not quite, the API isn't quite solidified to the point where people can do that. But the thought is to allow people to create views for the chessboard however they want. So if you want to create a 3D view, you can do it. If you want to create a 2D view that allows for mouse input, totally a thing you can do. Right now we have, I guess, technically 3 views. We have a console view, a TDL view, and we have a Twitch view. So the Twitch view actually doesn't display anything, but actually pulls the Twitch chat in and processes it. And actually, while I'm talking, we can actually just be running this thing, right? So let's go to BS.CHESS, Python app.py, and I can just slide this over here, I think. Make sure I got it. Yeah. So, or I could kind of let this live over here. And if you want to enter chess moves into the console or into the chat window, actually, they should work. So A2, A3, my favorite opening move. Yeah, and then it registers. We display my move and the pawn moves. Cool. So let's go ahead and enough introduction. Let's go to the first segment, the design phase. We need to figure out what we're going to build and what it's going to look like. Oh, interesting. Invalid literal int for base 16. Oh, somebody had interesting. So my color parsing broke. That's curious. Twitch chat view input. Let's pop open the ID and just take a look at that bug. Um, it looks like somebody, maybe Louis or Nixrod, somebody's name color came across in a way that we didn't expect. So let's take a look at that. Let's look at our Twitch chat input view, and we got the error on looks like line 71. I can close this out. Yeah, let me just put a breakpoint here and see what's actually coming across the wire. Yeah, so if you folks want to go ahead and enter those moves in again, yeah, right now for input parsing, I just make sure that it's I use a regex to match up things that it should be. So this is A2, A3. Okay, so Nixrod. Okay, so we got a couple events in here. Let's just take a peek. So player name is Nixrod. Event tags. Let's take a look at that. So event tags. Can I want to embiggen that. Color is actually strange. So color is null. I'm not sure why Nixrod. I'm not sure why your color is a null. That is curious. So we can handle that. Yeah. So player color equals event or tags dot color dot strip. Let's do this. If not player color equals what white. I think it's fine. I think that should be the default. And then we could say hex color is just equal to player color dot strip. And let's take a peek at this and make sure it does what it's supposed to do. You know, I don't know, because mine comes across just fine. So my player color, if I step, is represented just fine. It could be a bug in the Twitch observer, and that works as expected. So if one of you gentlemen want to also input a move, we can double check it. Okay, cool. Yeah. Thank you, Nixrod. So now your player color is set. No, your player color is that. So we'll set it to white, and then we can do all that stuff. And then Louis Carl, let's see what his player color also comes across as empty. Yeah, let me just take a look at this then. Let me debug Twitch Observer then and see if it's happening there. So again, if you guys could input another move, that would be helpful. Please, Louis or Nixrod. There we go. So if tags. So the tags I'm being sent across are what? Tags. Yeah, your color is being sent across as a null string. Yeah, if we look at the yeah, so Twitch is just sending across your color as a null string. Have you set it manually? Looks like Louis set his. Let's see if that changes now. 5, 9. Yeah, so it looks like yeah, so I think when Louis actually set his, it actually is coming across now. Yeah, there we go. Yeah, so maybe if it's unset, then yeah. Also, maybe if it's unset, let me just have it default to whatever the light gray is. Yeah, no, that's something good to handle. This is just in our Twitch input view here. So whatever over here, I think we had in our TDL view. Yeah, maybe we can tweak that here. Yeah, player history.player color. Yeah, I can't remember. I think you've been able to set your name for a little while now. Cool. Well, thank you folks for helping me track down that bug. Things are working a little bit nicer now. Let me just where are my colors up here? I guess I should just have it. Maybe, yeah, something like if fg equals colors dot white, fg equals colors dot light gray. Just so I just want to add some differentiation between the name and the move. Cool. All right, so let's think about what we're going to do today. Actually, I think I want to start trying to move forward on actually having the controller, or at least having a way of knowing the rules of chess. So this is building out our chess engine a little bit. So what I want to do is actually here, let's go ahead and I'll leave this running if you folks want to just kind of like just mess around with it while I work. I'll stick it on top of my head over here. Hopefully you can see that. And then over here I'll just work. So if folks want to poke around with that, feel free to. Unfortunately, I can't like hot patch or monkey patch the actual running Python code. That would be really rad. I know some languages support that, but right now I don't have that set up or know if it's even possible. Okay, so what we need to do is actually let's go ahead and commit our changes because these are probably not relevant to what we'll be doing next. So let's go ahead and just take care of that. Let's position this over here. I guess we need a new tab. Let's go to repositories, BS.CHESS, do a git status, and we have a TDL view and we have a Twitch chat input. Let's do a git diff and kind of remind ourselves what we've changed. So in the TDL view, oh yeah, this is just a little special case that we don't want white player names. I didn't want to change the actual like the controller or the model thing. I just wanted to change the way the Twitch is just handling it. Cool. Looks like Nixrod is moving pieces around. Yeah, so I think this is fine. Git add dot git commit fixing bug if Twitch player color unset. Git push. Git push. There we go. Okay, so now what we need to do is the way I've set it up is we just have a chess package here. And it has a variance package underneath that. And in there we have our debug variant. And basically what these variants do is they provide just one method that say generate moves, and whatever variant we're playing for a given board state, we will ask, please give us all the possible moves. And then what we can do is we can check any given player move if that is contained within this set that gets returned. We also use a generator. So we potentially will shortcut if we find a usable value. So what I want to do, I guess, is what is it just called the chess variant? Is it just called a standard variant, or what is the actual just the basic rule set of chess? Yeah, yeah, and also the wow. So yeah, there's all sorts of different variants. I guess we'll just call standard, unless you folks have a better name for me. We'll just say variant new Python file standard.py, and it needs to emit this function or this interface, and then that's going to be something similar to this, but this just makes every move valid, and we don't necessarily want that. We want to have we want to basically I've been looking at sunfish.py, and it's a pretty lightweight academic chess engine, and I think it does a lot of smart things. And I will probably kind of use some of the same algorithms that they use. So I think some of the things that they do. Also, let's take a look at our. So our model right now is just a 64 character string. So what one of the things that Sunfish, whoever implemented it, did is they actually they padded the board by two basically like white space characters in all directions as an easy way to determine if something is in or off the board. So I think that's probably a good way to go. Or I could pad it actually in the standard here. I could take this and I could manipulate the board state such that we have it padded, because I could do that for now. And if it's something we're always doing, we could think about if that's something that we need to actually just change the model. So what we really want is we want to transform it. So basically we want we want 10 columns, and we want 12 rows to be able to correctly identify if it's off the board. So the best way to do that is take our board state, and we need to create a set of substrings. We need basically 8 sets of substrings of length 8. We need to append white space to the front and the back, and then we can insert the additional rows before and after that as well. So we can do something like for I in range from 0 to 63, step 8. I think that will do what I want it to do, but let's just take a peek. We can always jump to the interpreter Python, and we can say list of range 0, 64, and 8. I think that's what we want. I think also 63 will probably give us the same result. Yeah, that's fine. Because this is basically the start index of our substring. So we could say substring is equal to board state. We're going to slice it from I to I plus 7. We need a new thing. So let's say board is equal to the empty string. And then board plus equals space. Actually, we do like this. Let's just do a format string, right? Not a format substring. So basically, we're going to pad each side with a single space, and this will help because so we need two at the top and the bottom, and we need one on each side because of the way the array wraps. And then board equals times 10 plus board plus was it times 20? Something like that, maybe. Let's try to debug this and make sure that I'm going to get the thing I expect I'm going to get. Since folks aren't playing this, I'll go ahead and close it. Let's also go to our controller, and then up here, we're just going to say from chess variants import standard as current variant. Stop, and debug. 283. Okay. Okay. So our board. Is this? No, this is not right. There's not enough spaces at the start. Actually, I think the Sunfish did that was very helpful was do a new line here, and this should just be times 2 and do 1, 2, 3, 4, 5, 6, 7, 8, 9 \n. Then I should be able to print that out and get something somewhat legible. 333, and then here in my, I can say print of board and console. Yeah, so we have, I think that's right. 1, 2, 3, 4, 5, 6, 9. Let's also do, what is the lin of board? 112. Is that what we expect? I was expecting 120. Because 12 by 10. So this board looks like we have 2 blank rows. What have I done wrong? Copy value. Let's take a peek. Okay, let's get rid of the quotes. And there's 9 characters there. 9, 8, 8, 8. Am I missing? There should be 10 characters, right? Should be 10 characters. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Am I chopping off? Oh, am I not getting enough? Looks like I'm missing an entire. Yikes. Oh, the slice is not inclusive. That's what was happening. Okay, so now our length is 120 like we expect. Excellent. And we have all the pieces that we expect. Okay, so this is just going to transform the board into something that we can more easily manipulate. Okay, cool. So that should be fine. And then now, again, I think what Sunfish did is they did some interesting things where we have basically like directions. So we have like north is equal to, that's equivalent to going up a row, which is equivalent to subtracting 10 in the array. And south is the opposite, where you're adding 10 in the array. West is equivalent to subtracting 1, and then east is equivalent to going 1 in the positive direction in the array. So if you think of it as a it's a two-dimensional array, but we're working with it as if it were flat. So this is how we can navigate through it, right? And then with that, we can actually build up moves. So something like, or they created a directions map. So we could say directions, or it doesn't matter, directions is equal to a dictionary. And we'll do it by character. So for the, let's say, yeah, so for example, these capital P's, so let's have a capital P. It's going to be a list of moves. And for now, let's just say that pawns can only move up a single. Pawns can only move. Well, so pawns can move. They can move north, and they can move north plus west, and they can move north plus east. But there are some rules about these latter two, but those are still valid directions for them to move. Louis is asking, your board is 10 by 10. Yeah, so the thought, Louis, here. So this should be, yeah. Let me finish this out. Okay, so we have we have 2 extra rows here, 2 extra rows here. We have an extra character on each side. Okay, so for our directions here, like north 10. So this, I believe, is this is array index 48, and if we want to move north, we will subtract 10, and that should, or no, so this is, wait, this is this should be 91, and if I want to move up 1, this should be 81. Which is fine, but the interesting thing is here is we can also check. So like the rook can move left, right, up, and down. Because we have this extra padded space here, we can check for out of bound moves a little bit easier, if that makes sense. So what we can do is we can say if so for the north, northwest, northeast, we can check. So this north, that's a dot, so that's contained within the board. Or if it's a lowercase letter, in the case of the uppercase letters, we're taking a piece, which is also a valid move. But if it's white space, then we've strayed off the board, and it's not a valid move. Yeah. Again, I pulled this from sunfish.py. It's a really cool, it's a really clever way of implementing things. I'm trying to keep things as simple as possible. I'm not lifting directly their code, but I want to disclaim that I have read through it, trying to grok how people build these move generators, and I think it makes a lot of sense. So for here, we have this pawn, which can move north, northwest, north plus east, right? So then, again, pawns are kind of the hard ones too. They have some special rules. Okay, so we want to. Okay, so this pads board with white space for easier out of bounds detection. Okay, and then now here we need to determine set of valid moves. Okay, so then here we're going to check every single square, and for every single square, so if Yeah, so if the square is empty, continue. L, okay, so if it's not empty, we need to say for, so we want to iterate over the potential directions that a given piece can move, right? Because basically we're going to go through every single square, and then when we find a piece, we're going to go through every possible direction, and for each direction, we're going to go as many squares in that direction as we can to build out a hopefully a comprehensive list of potential moves. So for D in directions at square. So this will look up the directions for a given piece. So let's just go ahead and complete this out. So we have our pawns. We have what else? We have our rooks. They can move. Actually, these are immutable, so we can actually just make these tuples. Rooks can move north, or northwest, east, and south. Right, that's how they move. Next are our knights. Knights can move. So make sure I don't goof anything, okay? So knights can move north plus west, north plus east. Here, let me do this in a clockwise manner so I can keep well, northwest, northwest, south, east, northwest. Okay, northwest, north. So then now go to west. So west plus west plus north, west plus south, and then now south plus south, south plus west, south plus east, and now east plus north, and east plus south. So those should be all basically the directions. So knights are kind of weird. Like for a rook, we have a direction, and they just move up to 8 spots in any given direction. For the knights, they only move just this one location. Bishops move diagonally, so that should look something like north plus west, north plus east, south plus west, and south plus east. That should be how bishops move. Queens, they move basically the same as rooks and bishops, right? Let's copy this, and then let's copy this. Okay. Kings also move the same as queens. They just move a single space. So that will be, right now this is just a direction map and not like a number of moves thing. That's going to have to be kind of like handled in a case-by-case basis. I think those are all our pieces. So these are all the direction. Wait, nope. These are for the uppers. I'm just going to duplicate this for the lowers. And why did it? Oh, PyCharm. Thank you for formatting all this stuff. Do the lowers. The lowers are exactly the same except the pawns. Pawns are south. Otherwise, the directions are exactly the same. Okay, so now for D in directions, so we have a direction, and we want to Hey, new obj, thank you for popping in, man. So then I guess we want to do something like for r in range of 8. Because on any given square in a chessboard, I think the max move you can actually make is 7, right? You can only make 7 moves in any given direction. Yeah. And then also take a pick of this debug. So I yield I and j. So this is a two tuple of basically it returns a chord. So we need to return a chord as well. Hey, Dr. Kegel. No worries. Late is fine. I'll probably be calling it here shortly. I just want to try to get this stuff going. Determine set of valid moves. Then range in 7. So for each direction. Dest is equal to I plus D, and this is D, and this direction needs to be multiplied by the range, I think. I think that's right. Range of 1,7. List of range of 1,8. Yes, that's what I want. Range of 1,8. Then this is D times R. So this should find the array, or the cell in the array that we want. Then if board at dest not in let's say valid square equals yeah, pawn, rook, knight, bishop, queen, king, pawn, rook, knight, bishop, queen, king, and dot. Those are the valid squares. So if board not in, valid square, continue. So this is our out of bounds check. So if we hit white space, we've gone too far. Okay. Which seems okay. Also, it might be nice to have a helper method to turn this back into a usable chord, because we were transforming it here. So let's say def index to chord. Yeah, this takes an index, and this should be, I do this everywhere, but it's just a little bit different. So what is it? Row equals index divide by 10 minus 2, and call equals index modulo 10 minus 1. Return row and call. I think that's right. This is just to clear out the padding that we have. So again, maybe we could start by just returning again like the equivalent of the debug moves, where it returns every piece can move everywhere. I think that'd be an okay place to start. Maybe. Let's try this. So then coord equals index to coord of best yield coord. I think that's okay. Let me look at the debug. Yeah, it just yields a I comma j, but this should pull out a tuple for us. So let's debug this. A2A3. Okay. If square. Oh, we're not even using our correct. So square and enumerate of board. Board. If square. And here I can get rid of these new lines just to make things a little easier. That was just for display purposes, but so if square in that, continue, because we don't care about those. Bug. 283. Actually, let me do this top rook, because that should be the first one. So A8, A6, or A7. Okay, so oh, Joshua. I need to check for containment. There we go. Okay, so this square should be a white space, continue. White space continues, so now we can set our breakpoint down here. So we get the first rook, which is the one we are interested in. Out of curiosity, this is I, what, 21? So if I did a index to coord of 21, I get 0, 0. That is good. That's good. Okay, cool. So then now we have our directions map. So directions at R should return all those. Okay. So for our first direction is -10. So that is moving. Up. So this we should hit we should go off the board, and we should not count this move, right? So step, so 1. So dest should be 21 minus 10 times 1. So this should be just 21 minus 10. So that should be 11. And then board at dest, not invalid squares. Yeah, so this is this returns white space because we've padded our board, and we continue. And actually, I need to. Yeah, so I need, instead of continuing here, I need to break, right? Because if we're off the board, continuing to check further along this ray will not help us. So let's break out of this one, right? Check to see if the move is off of the board. Okay, so back to our little example. Okay, so now we break and we go and we check a different direction. This is what we want to do. Okay, so now our direction is to the left, which should be also off the board. Okay, now we should be checking south. This is 31, which should be on the board, which should be okay. And we should get back a coord, which is I got that flipped around, so let me fix that. It needs to be column and row. Okay, let's check that again. Okay. Break, break, and then now this should be a valid destination. The coord is 0, 1, which I believe is correct, and we're going to yield that coord. And then also, yeah, so this should generate all the moves until we get off the board, I think. Actually, because we keep it between 1 and 7, this should never go off the board. And then now this is checking to the right. And that should yield all the chords there. So I think this is working okay. Let me just run it. And that was not a valid move, actually. I wonder why that is considered not a valid move. Do I need to do some flipping of the so this returns I comma j. So for square and enumerate word. So this is 0, 0 is what this is considering. And this should also be considering that as 0, 0, or similar. Let me try this again and see what on the other side of things where we're taking a peek. So here in the controller, this gets used by checking to see if a given variant. So we just check to see if a given move is inside a variant. So this move is spot 0 to spot 8. Yes, 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 yes. So my calculation for the chord is wrong. So let's fix that. So here in standard, it's not row call, it's it needs to be start and stop. So what I need to do, this needs to be, it needs to be column plus row times 8. Is what that needs to yield. We need to rename this too, but yeah. And this needs to be I comma to translate index to refactor. So we need to return of dest and of I. Pretty sure. Okay. Debug. Okay, so my move is 0 or 0, 8, and let's take a look at our standard here. 9. And I can just copy this and put it into a watch. Let's remove all watches. Let's add a new watch. Will be, yeah, and this is the very first one. So this is the one where this is, yeah, we're yielding this. So that's good. Then now, yes, that is a valid move. Cool. I also should be able to move this row rook from A7 to B7. That's fine. I should not be able to move the rook B7 to C6. It should not allow that move. Cool. So it looks like our pieces should uphold their directionality, I believe. So C7, C6, but C6, C7 should be not valid. Cool. Yeah. So we're starting to get some very basic logic here, where now the pieces honor the directions they can actually move in. Nice. Again, you could still do crazy stuff. So you can do something like C6, C2, because that's in the correct direction. It's just too many spaces, right? So that can be a future Joshua problem. We can take care of that tomorrow. But I think this is certainly an improvement, because now, for example, the queen, so D8 to A5 should work. Yep. But the queen can't. Hey. Yep. Yeah. Again, folks, whenever you see me debugging stuff, feel free to jump in. And also, for those of you in chat, is it big enough to actually see, or should I make this even bigger? Yeah, so that was, sorry, I keep forgetting to call out the different segments and phases. So we need to wrap up the implementation phase, and we need to get onto the QA phase. Cool. So yeah. So Nick's route is confirming that this is it's legible, which is good. Sorry, let me keep that up top. So again, let's take a look at this and make sure that there's nothing that we should be look like, but it looks okay in theater mode. I'm not quite sure what you mean, Nuabj. Equal sign looks like a minus. Oh, so you're talking about the actual, okay, so yeah, you're talking about the actual text here. Okay, so either this or okay, cool. Yeah, because I already bumped it up pretty big, but hopefully that's readable. Also, the chessboard hopefully is readable as well. Cool. Yeah, so. Hey, Polythream, thanks for popping in. Yeah. Oh, today's been an interesting day. Just one of those nights where I can't sleep, and being a father and self-employed, it's a tough day. You gotta have discipline and just get things done. Cool. So what are the QA considerations for this piece of code? How can we be sure that we're generating all the possible moves for the board? Because for example, like we can't move pieces off board because I don't allow the regex to be input. I mean, I could just test the. I could just not test. But I could just check real quick here in this generate moves. To see. So. So this is a. Okay, so the 340 possible moves. All the X chords should be Let me just try a few quick list comprehensions just to make sure that our move set is within the range that we expect. So so we'll do list comprehension. Say I for I in this. If I at 0 equal to 1. That's fine. Now equal to 0. Empty list. Okay, so we're not, so no moves are generated off the board that direction. What about the other direction? So this should be 9. So that's the far right side of the board. And then 10 also should be, okay, that's good. Then to check if I at 1 less than 2. Oh, sorry, the wrong way. I at all right. No, that is our y chord. Right, these are coming back translated out. Yeah. So that should be fine. Less than 0. Yeah, because these are not XY chords. These are just greater than 63. Yeah, I've just done some basic manual testing, and that's always kind of the least thorough type of testing to do. I mean, would you folks be interested, or you think it'd be valuable if we wrote tests for this? That might be overkill. I mean, we can keep doing some exploratory testing. That would be fine, but did we set out to? So did I don't think I didn't even record what I wanted to do today. Goals for today 1. Yep. So I fell off the. I did not be good about documenting these today because I want to be clear about documenting our goals for a given session, so that way we can be sure that we've actually accomplished our goals. But we will try to do better about this in the future. I guess the last thing I need to check manually is just the knight. Make sure the knights move like knights. So B1, C, 3. B1, C. Yes. C3, B1. Yes. Okay. So the knights move like knights. Unfortunately, they could probably do something like D1, F5. Yeah. So we eventually, so that's going to be a future Joshua problem, is to figure out which pieces only move once and which pieces can slide and when to stop. All that goodness. Okay, so I think we'll call it a day. Thank you for all of you who hung out with me while we're working on this. Sorry, I'm tired and a little bit scatterbrained today. Tomorrow will be better. Tomorrow we will continue on with our chess engine improvements, and hopefully this week we can get the chess movements for the standard variant of chess down, and then maybe we can turn to actually trying to. I'm crazy for thinking this, but I would like to try to also get a server client implementation too, so we can have so we can have like a remote client, so people can connect to the game I'm playing and not only play through chat, but they can also play through just manipulating a view on their end. I think that'd be a cool exercise. I've never implemented a multiplayer game in that fashion before, so that would be fun to monkey around with. Again, it would be some of me learning on the fly, but hopefully that would be valuable to some folks. Okay, so I am Joshua. This has been BS Chess, my lunchtime project for the near future. I have some cool ideas for the next lunchtime project. At the most recent Twitch developer announcement, they announced some really cool stuff they're improving with the API on. I think I want to play with that next lunch break stream. You can follow me here on Twitter or here on Twitch. Over there on Twitter, Joshua Skelly. I post all the weird stuff I do there. I'm a Twitch affiliate, so if you want to subscribe, I would love that. I consider it to be like a tip jar. Right now, for this month only, Twitch is running a promotional called September, which you can probably guess how they arrived at that one. But for September, if you've never subscribed to me before, subscribing to me this month is half off, and I still get the same benefit. So that's cool. So if you've been waiting for a good reason to pull the trigger, why not do it now? That would be awesome. I don't make a lot of money off of this, but maybe I can buy. I'm thinking either maybe more hardware or maybe tickets to events or something. I don't know. I'm trying to figure out what to do with it. But for me, it's just a nice vote of support. I have 12 lovely subscribers, and in no particular order, they are Fifth Elephant, Nixrod, Mrs. Beefy 1111, New Obj, Neil Slichter, Nofield, SG Bazzi, A Literal Train, Smith, Dr. Kegel, Glass Casket TV, and Codrake. Thank you, you fine, wonderful, handsome people. All right, have a good day. I will be back tomorrow, same time, same place.